So stroke out the word graphing, add the general solution for the title here, and we're going to do 4 questions as a warm-up. 2 calculator, these first 2 are calculator questions, and 2 non-calculator. Now you have space, you can either use the column on page 572 to start, and then continue on the space on page 573 at the top, because we're going to do 4 questions. This is a review of Chapter 6. How do we solve for theta? We're going to have to use our cast rule. We're going to have to use reference angles. And we're just solving once around the circle from 0 to 2 pi. The first 2. Did you get a reference angle of 0.730? And then it would be negative, so you're looking in quadrants 3 and 4. 3.87 and 5.55. For the second one, get tan by itself. Negative 3/8. Again, when you're doing your reference angle, it's always the inverse of the positive value. And then tan is negative in quadrants 2 and 4. First one's non-calculator because when you get cos by itself, you get cos equals 4. Not on your pi plate, but it's not possible if you tried to draw the triangle with the adjacent side being 4 and the hypotenuse being 1. It's a very hard triangle to draw. So it's not possible. Anytime sine or cos is bigger than 1, it's going to be not possible. And so therefore it is eligible to be on the non-calculator part of a test, quiz, or exam. The next one here, root 3 tan theta plus 1 equals 0. Now, solving for it, getting tan by itself, you get negative 1 over root 3. And this can be scary initially because you don't recognize it. You have to remember that you can, if there's a value with a square root on the bottom, you can rationalize the denominator. If you do rationalize the denominator, all of a sudden it turns into a value that you do recognize from your pi plate. That's part of our pi over 6 family. It's negative, so it'll be in quadrants 2 and quadrants 4. So what do we add to this now that we're going to Chapter 7? Well, we just solved this between 0 and 2 pi, and we found our answers to be 5 pi over 6 and 11 pi over 6. I could have said, can you solve it between 0 and 4 pi? Well, then you would still find 5 pi over 6 and 11 pi over 6, but then on the second time around, you would get another answer coterminal of 5 pi over 6 and another answer coterminal with 11 pi over 6. Yeah, this one would be 17 pi over 6, and this one would be 23 pi over 6. And I could have said, solve it between 0 and 6 pi, and you'd be like, oh. You have 5 pi over 6 and 11 pi over 6. Second time around, you'd have 17 pi over 6 and 23 pi over 6. And then the third time around, you'd have 29 pi over 6 and 35 pi over 6. And what we're getting to in Chapter 7 is something called the general solution, where I say, you can go around as many times as you'd like. Write down all of the answers. And so all that does is it combines solving between 0 and 2 pi, which we already did, but it also combines coterminal angles. How do I write all the coterminal angles with 5 pi over 6? How do I write all the coterminal angles with 11 pi over 6? And so we're going to write this like this. We're going to first find our answers between 0 and 2 pi, which are 5 pi over 6 and 11 pi over 6. And then we're going to say, if I wanted to write all of the answers, which is called the general solution, I take those 2 answers that I have, and I add 2k pi, which is just 2 pi times k, but for whatever reason, we write the k in the middle now. If it was in degrees, you'd write 360 degrees times k. And then we write a straight line to say such that k is an element of the integers. So that would be the general solution. And we're going to write our instructions for the general solution on the top of page 574. What we just did was this. Whoops, not that. What we just did was this, the general solution. Two ways the general solution is asked. It can either say theta is an element of the real numbers, meaning that you would solve all answers from 0 to forever and 0 to negative forever. So we solve like normal from 0 to 2 pi. Then we take our solutions and add 2k pi to them. That's step 2, is just writing coterminal angles. So step 1, you already know how to solve between 0 and 2 pi. Step 2, you already know how to write coterminal angles. And now we're just putting those ideas together for solving equations. So instead of doing example 1 at the bottom, you can put an X through example 1. We're going to create our own examples at the bottom. Here is, where am I? What is happening to my screens here? Here, yeah. Whoa. Everything is getting mixed up. There, example 1. Here's our first example. We're going to try to solve for theta, where theta is an element of the real numbers, for 7 sine theta plus 1 equals 0. So we start just like solving normally from 0 to 2 pi. You'd get sine theta by itself. You do sine inverse of positive 1/7 to get your reference angle. And then you would think, well, sine is negative in quadrants 3 and quadrants 4, so our answers would be pi plus our reference angle and 2 pi minus our reference angle. So taking out our calculator, those would be the two values we would get. So part 1 of the general solution is just the same solving you've done before, solving between 0 and 2 pi. Part 2 of the general solution says once you've solved between 0 and 2 pi, all you need to do is take your answers and write all the coterminal ones with them. So in order to write all the coterminal ones with them, you take each individual answer and go plus 2k pi. Here is one for you to try. I'll put up the answer if you want to check how you did. This is just the answer, no work shown. So 1.77 and the 4.51, those would be the answers between 0 and 2 pi. And then you'd add 2k pi to make them coterminal.
So it's just a little bit faster than writing every single answer.
It's a little bit faster than writing every single answer, all infinite of them.
A great way to try to, like on the unit circle answers, is to have, let's say it's the pi over 6, right?
Mm-hmm.
Have 2 pi over 5.
This example will combine a bit of everything. We're going to solve for theta, where theta is an element of the real numbers. So we're going to have our general solution. It's a quadratic equation. So at first you try to factor that, and after attempting to factor that a couple of times, you're going to realize it does not work. And so you go to your formula sheet where they have for ax squared plus bx plus c equals 0, they have the quadratic formula. But with the quadratic formula, it's x equals, but we don't have x squared, we have tan squared. So in our equation, we would have tan of theta equals, and we'd have negative b plus or minus b squared, which is 9 minus 4 times a times c divided by 2 times a. And simplifying this, (9 plus 28 is 37 over 2. Well, the plus or minus just means one equation you'll have with the plus sign. So tan theta would equal negative 3 plus the square root of 37 over 2. And the other side, you would have it with the negative sign, so it would be negative 3 minus the square root of 37 over 2. That is not on our unit circle. So it is a calculator question. It's not one of the ones we know. It is on our unit circle, but not a value that we know. So we're going to have to find our reference angle. How do we find a reference angle? Well, we go to our calculator, and we would go tan inverse of, I'm going to use my fraction button here. Now, when I type in negative 3 plus the square root of 37, one of the things I should have done before I even typed this in is ask myself, is that number positive or is that number negative? Because we always do the inverse of the positive value. So a little bit of mental math estimation. Is negative 3 plus the square root of 37, is it going to be a positive number or a negative number? It's going to be positive. So this one's okay. We can just push enter, and we get a reference angle of 0.995. And we also need to know that it's positive because now we're going to take that answer and find it in quadrant 1, which is easy because it's exactly the same as our reference angle, and quadrant 3. Well, in quadrant 3, you would go pi plus your answer from before, your reference angle, and we get 4.14. However, over here, negative 3 minus the square root of 37 is for sure negative. So when we go to our calculator to go tan inverse, and we have to put in a positive value, how are we going to do that? Well, I could multiply it by a negative 1, and that, if I multiply it by a negative 1 and change the top, I'll get 3 plus the square root of 37 over 2. 1.35. My reference angle. I want to show you that if you happen to have typed it in with the negative signs. So you had subtract here, and you still had a negative 3 out front. And you type it in. For sine and for tangent, it just so happens that if you do the inverse of the negative value, you will get the negative reference angle. But that doesn't work for cosine. So you can't just change it from negative to positive afterwards, because cosine does something different, and you're going to miss it. So we still have to make sure we recognize that this is a negative answer, and then find our reference angle, And I'm going to take that reference angle that we got from before and store it as x. Because now to find my angles, tan is negative in quadrants 2 and quadrants 4, sorry. So in quadrant 2, it'll be pi plus my reference angle. And in quadrant 4, it'll be 2 pi minus my reference angle. What? Okay. No, not pi plus my reference angle. Sorry, quadrant 2 will be pi minus my reference angle. That looks more reasonable. So I will get 1.79 and 4.93. This was step 1. We solved all of our answer between 0 and 2 pi. The only thing we have to do with the general solution then is after we've solved between 0 and 2 pi, write out all of our answers, and they don't have to be in numeric order, but it looks nice if they are. Add 2k pi to each one. Where k is an integer. And then we have created a general solution. So questions for practice are 5, 6, and 9.